Hello guys, I hope you're doing great. It's Napoleon. We are still on derivative. We are finding the derivative of cotangent. So we are still applying the rules or the principle or definition of derivatives or using what we call first principle in deriving cotangent of x. So we start with using the formula. The limit as h approaches 0 of f of x plus h minus f of x divided by h. We therefore substitute into our formula. Then after substitution into our formula, we know that our cotangent of x is actually equals to cos over sine cos x over sine x. We therefore convert it into cos over sine with the using as it's written here. So here, since we having our inside values x plus h, we therefore have our x plus h. Then on the next step, we therefore look for the lowest common multiple or lowest common denominator. So for us to get a lowest common denominator, we therefore have to cross multiply. We multiply the denominator and the numerator on the other side, and the denominator and the numerator from the other side. We therefore get our cos. Then we therefore get this, our cos x plus h multiplied by sine x minus cos x multiplied by sine x plus h, which is divided by our common denominator here. Here's our common denominator, sine x plus h multiplied by sine x, which is divided by our h. So our h is from our original formula. Therefore, moving to another step, we therefore elongate our cos plus h. So we are having cos plus h. It has a special identity, which will actually give us cos x cos h minus sine x sine h. Note that the identity is different from sine and cos. So on cos, when we are actually having a plus sign, that means our formula is going to have a negative sign. But on sine, if we are having a positive, we are therefore going to have a positive even in our formula. So you can actually identify it here on the steps. Therefore, we take our h and we multiply it with the denominator there, because when we actually having when you are dividing you can actually just reciprocate and that division by actually multiplying. So now we are here. So we have multiplied, we have folded over. So here we have multiplied throughout, since our sign here and our cosine here, cos x, and our sign, they are outside the brackets. We therefore multiply throughout the bracket. Then we get this then we therefore look for a common factors to add or cancel. But one common factor we can identify is sine x cos h, and because even this side we are having the same, but the thing is they are different with signs. That means they are going to cancel. So this is going to cancel this, then we will be left with this and this. So we don't actually make any changes in our denominator, so we just leave the denominator as it is from the way we got it. Then now we are here, so we can now identify a common factor. So here you can see that we are having sine h and sine h. Therefore we take out our common factor, then we are left with negative sine squared of x minus cos squared of x divided by our denominator here. So we don't actually do anything to our denominator until a later state where I will show you what we are actually going to do. So now we are taking out negative 1. So you can actually put 1 here, but even if you don't place it, it doesn't actually matter. So we take out a negative outside, meaning that we are going to, so note that both our sine and cos, they are actually negative. So when we take a negative outside, that means they are both going to be positive. And you know this identity, sine squared x plus cos squared of x equals to 1. Therefore, we are going to have 1 here with our denominator. So one thing we did up here is that there is another, there is a limit, a special limit of sine h over h as the limit h approaches 0, which is equals to 1. Therefore, by multiplying with that 1, everything just remain the same. So we have no change. But it's very important that you actually identify this limit. You being able to identify this limit is going to make your problem solving much simpler. We are therefore here. We are almost done. Therefore, we substitute. Note that when we substitute, we therefore remove the limit h as h approaches 0, because now we are doing what? We are substituting 0 in a place. We are substituting 0 in the place of h. I'm sorry. Therefore, we are left with this as 0, x plus 0 is actually equals to x. Therefore, we are left with negative 1 sine squared sine squared of x. So negative 1, this is a very important identity, which says which says 1 over sine squared of x is actually equals to cosec squared of x. But because here we are having a negative sign, we are retaining the negative sign. Therefore, our derivative of cotangent of x equals to negative cosecant squared of x. I hope, guys, you enjoyed this video. Can you please subscribe and like, as I will provide you with more solutions on calculus and also mathematics overall. And if you have any mathematics question, you can actually ask it on the comment section, and I'll reply with a video. Thank you.